Hello, I'm Tim Menzies. I'm from NC State and I'd like to talk to you about assessing what we believe about software engineering. This is an MZ 2021 paper. There's a URL here showing the PDF to it. It's an archive 2006-05060. And this is work with Srikanth, William Nichols from Software Engineering Institute, Fahmid Fahid from NC State, and myself. And what we're worried about are all the biases that confuse us about software engineering. We are worried that what we believe about software engineering might not actually be true. If we go to the list of human cognitive biases in Wikipedia, we can find 128 different ways that people routinely get things wrong. So if we ask people, are they correct in their beliefs about things like how program size affects defects, about how programmer experience affects production rates, about how programming languages affects the defects generated in those languages, and all these matters, we're worried that these kind of cognitive biases might mean that what we believe about these things up here might actually be wrong. To check that out, we asked Bill Nichols for data. And Bill Nichols, as an SCI, is one of these people who, as part of the Personal Software Process Research Program, traveled around the world and worked with thousands of developers recording their activity. And by thousands, we mean thousands. Between 2006 and 2014, Bill Nichols was involved in thousands of different sessions where 5,424 developers spent 4 hours with Bill working through the same set of 10 exercises. These exercises were graded simple to very hard. And in those process, he logged activity associated with introducing and fixing 124,000 defects. And so we asked in that data, can we find any evidence for beliefs like this? Now, before we go into those beliefs, one thing that was apparent from the start is we couldn't check exactly these beliefs in that data. We had to use partial indicators. So we looked at these beliefs and said, if these beliefs were true, what would we see in that kind of data up there in 3? So one external validity issue with this work is, did we use appropriate indicators to map from these beliefs to that kind of data? So if you want to challenge our results, that's certainly a place to start. However, we spent a lot of time talking about those indicators. The reviewers at MZ were very kind to help us get those right. And so we think that it's pretty true to say that switching languages can actually lead to less defects. And we think it's pretty true that object-oriented systems do not lead to less defects. And we're pretty sure that the more time you spend up front thinking about the work before you do it might actually mean less rework subsequently. However, we warn you that that particular effect is not very strong. Another strange one we found was that in terms of the difference in behavior between people who've been coding for more than 5,000 hours, wasn't much different to those less than 5,000 hours. Now, what's the general lesson from what we've done down here? And that's what point 5 is about. Well, the first thing we point out is this threat to validity about the indicators. We think we got the indicators right. You should read the paper to see if we're wrong. Secondly, quite apart from the 4 things we explored here, we think there's a whole class of beliefs in software engineering which we've stated, accepted in our community, and we're just not checking now. There's many things we found in the literature that talked about a wide variety of beliefs, but if we asked for how much has that been tested for, the evidence was pretty weak. So we believe much more than we actually test. So if you want one takeaway from this particular talk, let's do more checking about our core beliefs. The other thing I want to say is, let's doubt more. We found many commonly held beliefs were not supported by the available evidence. Now, what do we do about that? We think that there's a lot of cognitive biases that are confusing us, making us think things about software engineering which are not true. So my advice to you is do a lot more empirical software engineering, not just about these hypotheses, but about everything else that we think is true up there in 2 and everything else. We need more empirical software engineering. We need more doubt. We need to be better scientists. We need to check our core assumptions. And that's the message of this talk. Thank you very much for listening. Hope you have a great time at ICSE. Bye now.